Okay, so today you're doing an extension, an activity. You need to do the activities on pages 266 and 267, and then you need to answer the 6 questions that go with them. But I'm giving you some background right now, just so you know what you're talking about. To start off with, remember that a rational number is any number that can be written as a ratio between 2 integers. An integer would be like -5, -4, -3, -2, blah, 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 1, 2, 3. So all of the whole numbers and their opposites are considered integers. So a rational number can be positive or negative, written as a fraction. That's the rule. Any decimal that repeats or any decimal that terminates or ends is considered a rational number. So what we're looking at today is we're looking at sets of numbers and whether they're closed under certain operations. So a set of numbers is just a group of numbers. All of the integers, that would be a set of numbers. And just as an example, the integers are closed under addition, subtraction, and multiplication, but not division. So here's what that means. To be closed under addition means I can take 2 numbers from that set and add them together, and I get another number in the set. So for example, if I were to take any 2 integers and add them together, I will get another integer. There's no way for me to add 2 integers and somehow get a fraction or a decimal or the square root of 8. I can't do that just by adding 2 integers. So the integers are closed under addition. They're also closed under subtraction. No matter what 2 integers I pick, when I subtract them, I'm always going to get another integer. And again, for multiplication, if I multiply 2 whole numbers or their opposites together, I'm going to get another integer. So all of our integers, if I were to add them, subtract them, or multiply them, I'm going to get another integer. So I would say that the set of integers is closed under addition, or the set of integers is closed under multiplication. But if I think about division, if I take 2 integers and divide them, for example, I take 3 and divide it by -2, I get -3/2. -3/2 is not an integer. This is, can be written as -1.5. That doesn't show up on my integer list. This isn't a whole number or its opposite. So the set of all integers is not closed under division. So what you're going to be doing is you're going to be looking at a couple of operations with rational numbers and irrational numbers. Remember, rational means it can be written as a fraction. Some examples of irrational numbers would be pi. Another example of an irrational number would be the square root of 2. No number squared or no whole number squared gives me 2. So the square root of 2 is irrational. The square root of 3 is irrational. The square root of 11 is irrational. All of these square roots that don't have perfect square factors, or that don't have perfect squares, all of those are going to be considered irrational numbers. So you're not actually going to be proving whether or not these sets are closed. You need to know quite a bit more math than what you guys know. But you will be just making, a general assumption like, well, it seems like this is tending toward closed, so yes, it must be closed. You can prove that it's not closed just by showing an example of, like, here's my example proving that the set of integers is not closed under division. I gave an example of a division problem where I didn't get an integer. So you can prove that something is not true, but you're not going to be actually proving it's true. You're just going to be saying whether it seems like it's true or not. So that's what you are going to be working on for today. So have fun with that.